Let's go over conditional probability. So conditional probability is the probability that an event will happen given that another event has already happened. So an example of this would be the probability that a student would pass an exam given that they've completed their homework. Now we can write it like this, with the probability of A given B. So that vertical line, we read that as given. So that's the probability that event A will happen given that event B has already happened. We can also figure out if the variables are independent of each other or if they are dependent. So if the probability of A equals the probability of A given B, then the two variables are independent. So if the probability that a student will pass the exam is the same as the probability that they'll pass the exam given that they've done their homework, if those two probabilities are the same number, then the two variables are independent of one another. But if those two probabilities do not equal each other, then we can say that the two variables are dependent. So let's work through an example here. We're given a table with freshmen, sophomore, junior, and seniors, and a couple different majors that they have. With that table, we can then find the following probabilities. The probability of a freshman given that they are a marketing major. And then we'll flip the two variables and say the probability of marketing given that they are a freshman. And we'll see how just flipping them from one side to the other there is going to make a difference in how we approach this calculation. Once we find those two probabilities, we'll then talk about whether or not the major and the class are independent or dependent variables. So first, the probability of a freshman given that they're a marketing major. Whatever your given is, whatever that second variable is, that becomes the population that we care about. So we are only looking at the marketing majors. Now, 15 of those are freshmen. So the probability that the student is a freshman, given that they're a marketing major, is calculated like this. We take that 15 and we divide it by the 59. The 59 is the total number of marketing majors, because that's the population that we care about right now. So 15 out of 59 gets us 0.25. So that would be our probability there. Now, let's find the probability of a marketing major given that they're a freshman. So now that's the population that we care about. Just the freshmen. So again, there's 15 of them. But instead of going 15 out of 59, we're now looking at 15 out of 27, because we are dividing it by the total number of freshmen. So 15 out of 27 gives us 0.55. So now we can find out if major and class are independent or dependent variables. We just found the probability of marketing given freshmen. So that will be our A given B, which means the probability of A is just the probability of a marketing major. So marketing given freshman, that was our 0.55. Now, the probability of just a marketing major, we take all of the marketing majors and divide that by our grand total, the 123. So 59 out of 123 tells us that the probability that a student is a marketing major is 0.47. So those two numbers are close, but they do not equal. And since they do not equal, that means that the two variables are dependent.